Okay, cubes and cube roots. The good news, is that we've done cubes before. Do you remember what they look like? Can you show me with your arms? Oh, you're tracing them. That's not as fun as I was looking for this. Wait, is that backwards from your perspective?
Yes.
There we go. Thank you. Yes, that would be positive from your perspective. So we we know what cubes look like. In fact, let's just remind ourselves with a table of values. In fact, that's always a safe way to go. If you get stuck on something and you can't remember what it looks like, well, start plugging numbers in until you figure it out. Because if I cube 0, I get 0. And if I cube 1, I get 1. And if I cube 2, I get 8. And if I cube 3, 27. And then I'm probably off the graph, so I'm not writing anything down anymore. What about the negative side of things? Yeah, it stays negative, right? The cube sort of preserves the negative, as opposed to the square, which wipes it out. So yeah, those are our sort of key points. And then transformations, by now you are all-stars at transformations. So I don't feel bad at all picking on people for this first one. I can find someone who's here. So Luciana, how about tell me one of the things that has happened to number 1? Up 2. Up 2. Yep. Liam, what else has happened? Up 2, right 4. So let's go right 4 and up 2. Be careful with the scale. Right? It looks like not most of these. Some of these are scaled by 2, some are scaled by 1, so always be careful here. Up 2, right 4. So there's my new origin. Sometimes we put the little cross there if it's going to be asymptotes. That's not the case here. We're going to go through 0, 0, so I can leave that there. Over 1, up 1. Again, be careful. That means half of a grid marker there. On each side. And then over 2, up 8. 2, 4, 6, 8. 2, 4, 6, 8. And so there's our cubic graph. Lovely. How about number 2? Excuse me. Thank you. Logan, what the transformations have happened to number 2? Left 3. Dontre, what else? Stretch by how many? Oh, you're going to get them both at once. You could say stretch by -2. What's another way to handle the negative? It's flipped. So probably wiser to say that, but it doesn't ask us for the transformation, so I guess you don't have to list them at all. So left 3, and since I'm going to stretch by 2, I'm going to write down my basic points here. I'm not going to write the negatives down. I'm just going to know that I'm going to use those on both sides. Who gets the 2, the x values or the y values? The y values. You remember this. Some will multiply by -2. Others will just multiply by 2 and just know to flip it over. So either one. So over 1, down 2. Again, careful with the scale. Left 1, up 2, because we're flipped. Over 2, which puts us right in the middle of a grid marker again. That's okay. And then down 16. That's way off the graph. 2, 4, 6, 8, 10, 12, 14, 16, I guess, if we want to put it on there. And same thing on the left side. Back 2, up 16. 2, 4, 6, 8, 10, 12, 14, 16. Obviously, you're just kind of eyeballing it after there. But that emphasizes how steep this thing is. But we were expecting steep, right? Because it was stretched. So, not surprised that this thing got, elongated, stretched. All right, that's old news, right? We've done cubes before? Okay. Maybe. Well, what's next? Cube root. Okay, so a cube root, let's talk about the parent function first. In fact, let's just graph maybe not even graph, let's do a table of values. And we'll figure out what this thing looks like. So, can I plug in 0? I guess I should ask that before I write it down. Yeah, I can take the cube root of 0 and 0. Can I plug in 1? Yeah.
Oh yeah, it could just be 1.
Just be 1. Let's put the negatives here too. Can I plug in -1? Can I take a cube root of -1?
It would just be -1, wouldn't it?
Yep. As opposed to square roots, you wouldn't be able to plug in negatives, but cube roots you can. It feels like, well, can I plug in 2? I guess that's a weird... You could. The best answer.
It'd be a weird number.
It would be a terrible answer. So what's the next number that I could plug in that would give me a nice answer? 8. So let's plug in 8, because the cube root of 8 is 2. And -8 is -2. You notice anything about that table compared to the last table? Yeah, the x's and y's have traded places. But that probably makes sense since we're now cube rooting rather than cubing. Can you show with your arms or hands what you think this will look like before we... Okay, I like that. I see some. Yeah. Instead of like this, it's more like that. And that even is the right way as you look at it, I think. Okay, so we won't even graph a parent function. We'll just go straight to the transformations here. So, Karis, tell me one thing that's happened in number 3. Left 2, and Jack, what else?
-5.
It's
Up -5.
up -5. I suppose that is correct. That's not wrong. I'm going to simplify things and say down 5. That's okay. That becomes an issue. That's kind of a funny answer, but there's times in calculus where that kind of stuff matters because the question will say how much did it decrease by, and so it decreased by 5 is the answer, but you could say it increased by -5, and that would be true as well. So just be careful when you're reading word problems. But no, Jack was on it. Up -5 is weird, but not wrong. Okay, so left 2, down 5 puts me right there. And I don't know, maybe it would have been wise to do a little sketch so I know what I'm looking at. I know what the final product should look like. I feel like that helps. Like when we graph parabolas, your brain knows what a parabola looks like. So when you get through graphing, you know if you're at least in the ballpark. So it should look something like that. We'll go over 1, up 1, down 1, back 1. Whoops, I can't count. The grid's throwing me off there. And some white out up here, but not anymore. So that point's not there. Throw him out. I'll use pencil. And then over 8, up 2. So from there, 2, 4, 6, 8, up 2. And then down 2 and back 8. 2, 4, 6, 8. So it's kind of the same shape as cubed, it's just been turned on its side. All right, number 4. This is the Jeopardy question, right? Here's the answer. Where'd it come from? let's list the transformations first. See if we can get some decent answers as opposed to Jack's answers. No offense. Ryan says up 4. Yeah, I think so. I think there's the sort of the new origin of that thing. So up 4. What else, Cooper?
What's that, right 2?
Right 2. I should have pulled one more, because what else has been done to this thing? It's been flipped. If it's been stretched, it's going to be hard to tell because these are already stretched out, so we'll be careful about being stretched. Let's see here. Does that go through 1, 1? Yeah. So I guess 1, 1's easy to spot, so that's an easy check. After that, you'd be counting 2s and 8s. But if it hits 1, 1, it should hit 2, 8. So we're okay. Or 8, 2, I guess. So cube root. Make sure we're good here. So Jackson, how do I accomplish the right 2? So I went left -2, indeed. Carson, how do I accomplish the up 4?
+4.
Where? That's good. At the end. And then Reese, how do I accomplish the flipped?
You make it go from like negative to positive, positive.
So where do I put that in the equation to make that?
At before the cube root.
Yeah. That looks weird. That looks like the root is -3. We just so negative cube root x minus 2 plus 4. And a y equals on there because it asks for any equations. Some of you have missed a few points along the way this year because you didn't put a y equals on something. It's frustrating to make a 99 for that reason, but so don't forget the y equals. Okay, so if you understand cubes, cube root is not that much more. Again, that's every day in math class. If you understand everything you're supposed to know, the next day is not that hard. So your assignment is this next page. No, we got time, and these are quick and easy. There's some curveballs on there. What's number 3? Well, what's that look like? That's the V. What's the table of values? Well, you just make one if you don't remember it. What's the absolute value of 0?
0.
And the absolute value of 1? And the absolute value of 2?
2.
Etc., etc. And then you combine that with what you know about what the shape looks like, and that'll help you get the whether it's flipped and the positives and negatives. Right. Anything else weird on the page? I would say not weird, but what's number 6? A square root. Well, be careful, it's not a parabola.
No, that's the square.
It's half of a sideways parabola, I guess. There are some parabolas on there, though. Number 1. Number 9. So, be on your toes. It's not all cubes and cube roots. Squares and square roots. Cubes and cube roots. What did you forget, Ryan? Did you really forget what a parabola looks like? Well, if you need a table of values, then you make a table of values, right? Yep. 0 squared is 0. 1 squared is 1. 2 squared is 4. So hopefully you've done those enough where you know the table of values, but it's not really that big a deal if you forget it. You just plug numbers into the parent function and create your table, and then use your transformations that you're so good at, and then graph the thing. So I think a easy worksheet.